Hi everybody, so we're starting the last unit of the year now. There's a lot of lessons in this, but we are not going to do all of them. So I'll let you know before, probably at the beginning of each week, which lessons we're going to do, and we'll still do them generally in order. So what I would suggest for this is don't print the whole packet because you're not going to need everything from it. Um, if you are the type of person that likes to write on the notes no matter what and you have access to a printer, print the lessons from the pages that we're doing, and I'll let you know which lessons those are. Um, Print the pages from those lessons and work on just those. Don't print the extra stuff. Or if you want, you can just print out the homework pages and take notes for the other stuff just on a separate sheet of paper. I still recommend taking notes even though it's not in the packet, because you don't want to have to rewatch the video to figure out a formula. You want to write down the important parts and save those and put them in your binder for later. So we're going to start with lesson 1. I'm going to do lesson 1 in 2 videos. So we've got the one today, and then Monday of next week I'll give you guys the second half. Like always, I'm just going to be doing stuff on Mondays and Wednesdays. So I'll give you guys the second half of this video on Monday of next week, and then we'll do lesson 2 on Zoom, probably on Wednesday then. And I'm still not sure what I'm going to do with Zoom. We've been having low numbers for all of the sessions that I've done, so I might combine you all into one group, unless if I find out that we're going to be able to all be on track and have different groups for that. So that's the plan for this week and next week, and we're just going to get started on this first lesson. So for the first one, we've got an opening exercise that asked us to sketch a circle. Now, our circle sketches are not going to be perfect. You can use your compass if you want to, but still you could be slightly off using a compass if you don't use it exactly perfect. So this is just a sketch, and we've got our circle, which is called circle O, and whenever you've got something that's a circle with a name, it's always named after what the center is. So the center is O, and it has a radius of 5 units. Now I sketched this by knowing that a radius is going to be the distance from the center of the circle in every single direction. So 5 units all around. But I can't really see on a graph a diagonal line for 5 units. Okay, we'd have to use the distance formula for something like that. And this is just a sketch, so we don't need every single point. So what I did for this, which is what I want you guys to do whenever you make a circle, is you're going to go off of 4 main points. The 4 points that we know are going to be on the circle are going to be the 4 that I've listed right here. And those 4 are going to be on this circle because we know that if we go up 5, left 5, down 5, and right 5, those are all going to be points on the circle because we've got a radius of 5. So these 4 points right here are definitely on the circumference of our circle. So that's a good starting point for us. But what we don't know is we don't know about some other points. So the point 3, 4, point A, we want to see if that's on our circle or not. So 3, 4 is right there. Now I'm not sure if my graph that I have is totally accurate. I made the circle myself. I didn't use a compass. I didn't use a computer program. So I could be off. The point is right here, but maybe the actual circle was supposed to go around it or maybe underneath it, okay? We don't know exactly if it's on it or not, but it looks pretty close. So there's a couple different ways we can decide if point A is actually on the circle or not. And one way is that if the distance between the center and point A is 5. We want that distance to be 5 because if the radius reaches that point and is exactly on that point, then that means that it's got to be on the circle. Because in any circle, the points on the circle, every single point that you've got on here, is going to be 5 units away from this middle point. So let's do the distance. We can do the distance formula between those 2 points. Now point A is the point 3, 4, and the origin is 0, 0. So you can use the distance formula. Or the second way you can do it is to use the Pythagorean theorem, which you can do like this. So you just take that diagonal line, make that the hypotenuse of a right triangle, and then you can say, oh, this is 3, and this part right here is 4. So you can use the Pythagorean theorem to figure out what the radius is. Okay, so there's 2 ways to do it, and I'm going to show you both of those ways right here. So the distance formula, using the 2 points, you're going to get the distance for the radius to be 5, which is exactly what we want, so that means that A will be on the circle. Or you can use the Pythagorean theorem, which is 3 squared plus 4 squared equals r squared in this case, and we're also going to get the same thing, that the radius is 5. And we want it to be 5 because that's what it said up here. So that means that yes, it is on the circumference of the circle. So we're going to use that to answer some other questions. Okay? For this one right here, we've got a radius of 10. And something that's true about every single point on this circle right here is that all of these points are 10 units away from the center. Every single line that I can draw, every radius, if I draw it correctly, will be 10 units long. And that's because the radius equals 10. So we can use that to see if other points will be on the circle or not. So if we look at the point 6, 8, 6, 8 would be over 6 and then up 8 right here. So this is 6, 8. Now that point, let's just erase that for a second. If you look at that point right there, it looks like it's on the circle. It looks like it's either on it or very, very close to it. So we want to make sure, we want to prove that it's actually on the line, that it's on the circle. So I'm going to use the Pythagorean theorem. You can use distance if you'd like, but it's really the same thing. So we're going to find that this radius, we want that to be 10, okay? If we know that it's actually on the circle, then this has to be 10. So we're going to make sure that that's going to be 10. This part is 6, this part is 8. So if we do a squared plus b squared equals c squared, 6 squared plus 8 squared equals 10 squared, we're going to get 36 plus 64 equals 100, and that's true. Okay? 100 on this side, 100 on that side, they equal. So since they're equal, that means that this point is on the circle. So yes, it's definitely on that circle. It says to show that it is, so that means it was going to be correct anyway, because it's never going to say show that it is and then it isn't. But we can tell that it's definitely there because everything equals out. For this next one, it's asking us, is it on the circle? So since it's asking us, that means we have to determine it ourselves. So if we look at the point 4, 9, let's put it in a different color. Let's see. 4, 9, we've got 4, and then we go up 9. That's going to put us right there. So if you look at this point, right there is where it's supposed to be. We're not totally sure if that's right on the line of the circle or not, though. So let's check. So this is our point. This is 4, 9. We're going to do the Pythagorean theorem. And if this radius is 10, then that means yes, it's on the circle. If it's not 10, then that means it's not on the circle. So let's do the Pythagorean theorem again. So it'll be 4 squared plus 9 squared equals 10 squared if it's all on the circle. And what happens when we get that is that we're going to get 16 plus 81. And then 16 plus 81 isn't going to equal 100. It's going to equal 97. And since 97 doesn't equal 100, that means that this point is not on the circle. Okay? And the reason why is because Pythag isn't going to tell us that it's on the circle. It's telling us that it's actually a little bit shorter. Okay? So the length of the hypotenuse of this triangle here is actually 9 point something. Okay? So it's really, really close to 10, but it's not quite there. So that means the 0.49 is not on the circle. Okay? So since the Pythagorean theorem is really giving us a lot of insight into the points that are on a circle, we can use that to figure out the equation of a circle. Okay? So any point that lies on a circle that's centered at the origin, okay, so the center is always going to be where the x and y axis cross for right now, and then a random point that we've got on here, x, y, we can figure out the equation of the whole circle that we've got here based on just knowing this information. That we know x, y, if we had a triangle put in here, the x value is the same thing as a for Pythag, because that's the amount that we're going over. The b value for Pythag is going to be the same thing as y, because that's the amount that we're going up. And then the c value, that's our radius. Okay, that's the distance from the center to the circumference of the circle. So if we were going to do a squared plus b squared equals c squared for our triangle, we could just plug in x, y, and r to get our equation. So this right here is the equation of a circle. Okay, that's the equation of a circle with a center at the origin, which is the only thing we've done so far, and it's the only thing we're going to do for this half of the lesson. And then the next lesson we will do what happens when it's not centered at the origin. Okay, but this is going to be our equation. So this is the y equals mx plus b for circles. Okay, that's the one that we're always going to plug into or get some information from. So using that, let's talk about exercise 2. So it says that the point 5, negative 12 lies on a circle centered at the origin. So I drew a picture of that here. We've got 5, negative 12. We've got this circle. It's centered at the origin. And this point is on the circle. So that means if we put this little triangle in here, we would have a distance of 5 here and a distance of 12 here. We're not going to write negative 12 because we don't do negative numbers for distance. But if we were to, once we squared everything, it's going to make it positive anyway. Okay, so what we're trying to do here is we're going to try to find the equation of the circle and the radius. So I'm going to start with the radius because that's a little bit easier for us to do right now. It's just the missing third side of a right triangle. We know two sides, we're missing the third. Whenever we see that, we do the Pythagorean theorem. So we do the two sides, 5 and 12. We're going to take those two and we're going to square them both and add them together, and that will equal the radius squared. And what we could do once we've got r squared, you could, if you're just looking for the equation of the circle, leave it as r squared because that's what you plug into up here. But it did ask us for the radius, so we're going to take the square root of both sides, and that's going to be 13 for the radius. So the radius is 13. And to state the equation of the circle, we're just going to plug into our equation. Now, just like any other equation, we're going to leave x and y as they are, just like in y equals mx plus b. The x and y in there, we leave and we plug in for m and b. In this case, we're just going to plug in for r squared. So we're going to have x squared plus y squared equals r squared, and r squared is 169. You could also write 13 squared if you wanted to just plug in for r, but sometimes in like a multiple choice question, you might see it as this instead of 13 squared. You just need to know that they're the same. So we're going to use that equation to see if this point is on the circle or not. So we're going to take the x value and the y value from the point, and we're just going to plug it into the equation that we came up with. So x squared is negative 3 squared plus y squared, 14 squared, equals 169. And if they equal, then that means yes, it's on the circle. If they don't equal, then that means no, it's not on the circle. So we're going to have 9 plus 196 equals 169. And we can see right away that this is going to be greater than 169. So this means no, it's not equal. So no, it does not lay on the circle. So we can always use this equation whenever we have a circle that is centered at the origin. So what that means is whenever we've got a circle and the center is in the middle of the x and the y axis where they cross, the point 0, 0, then you can use this. But once we start to do a little bit more and take it off the origin, okay, so if we have a circle and the center is over here, then our equation changes because we're no longer having a triangle with the middle of it or one point of it being on the origin. Now we've got our triangle off of it, and that's going to change our formula quite a bit. So in an effort to keep this video short and not overwhelm you guys with too much information all at once, I'm going to stop this video here. I'm not going to have the lesson 1 homework be due for a while, so if you wanted to get started on it, the only one that you could really do at this point is number 2. But I'll give you guys some extra stuff for practice as well, so keep an eye out for that on Google Classroom, and you can submit all of that on there as well. Just a heads up for those of you guys who can't print this out, it's okay if you don't print it out. When it's time to do homework, I'm going to try and think of some ways to have you guys submit it without having to print it. So if you want to just write it on loose leaf and take a clear picture of that and send it, that works. If you want to use Kami on your computer, Kami is a program where you can edit things right on the computer and send them in. You could do that as long as you're showing enough work. If you can type it, that works too. There's MathType on Microsoft Word, and also Google Docs has an option to do that. But I'll give you guys more information on that as deadlines for homework will come up. So for right now, if you have any questions on what we've just done, then let me know. Otherwise, on Monday, I'll be giving you guys the second half of this lesson, and then the homework for this will be due next week.